There are four main components in a grid tie system: the solar panels, the electrical loads, the bidirectional net meter, and the inverter. In this house, the distribution panel and the inverter are mounted together on the wall. The inverter converts the DC electricity that is produced by the solar panels into AC electricity. The meter that was installed by the utility company is replaced with a bidirectional meter to measure the imported and exported electricity. Let's take a look at the flow of electricity throughout the day to see how the import and export of electricity works. It's early morning, and as soon as the sun rays hit the solar panels, the photovoltaic cells start producing electricity. The first energy bar shows how much solar energy is being produced. Somebody wakes up and turns on the lights. The second energy bar shows the amount of electricity used in the house. The solar panels are producing more electricity than the house needs. The excess energy is automatically exported to the grid. The third bar shows how much electricity is flowing in and out the grid. As the sun rises higher, the solar panels produce more energy. Around midday, the system reaches its peak production. You will be compensated for the electricity you export to the grid. The newly installed bidirectional net meter records the exported and imported electricity. The consumer is presented a bill at the end of a billing cycle. The total bill amount is the amount of imported electricity reduced by the amount of exported electricity. The result is shown in the net total display. When the system is exporting electricity, the meter is running backwards. The meter will not go below zero. When the system exports more than it imports, you get a credit. In a net metering system, you will not get paid for your credit. The amount is carried over to the next billing cycle or written off. It is a hot day, so the air conditioner is switched on. A large amount of energy is now consumed by the house. During peak hours, the solar panels on this house produce enough energy to power the air conditioner without the need to import electricity from the grid. But when dark clouds appear in the sky, the solar panels don't produce enough energy to meet the needs of the house. Then, the utility grid compensates for this shortfall. The solar panels and the grid are now jointly feeding the house. The same scenario happens in the mornings or the evenings. Whenever the solar panels don't produce enough energy, the utility grid will supply the deficit energy. During the night, the solar panels don't produce electricity. All electricity is imported from the grid. You can always rely on the grid to supply extra electricity when needed, except during a power failure. When the utility grid fails, grid tie systems will not operate, not even on solar power. This allows utility employees to fix the power line safely without worrying about solar energy systems that are still feeding electricity into the power lines. In areas with frequent power cuts, an additional battery backup system is advisable to supply energy in case of grid failure. Now let's take a look at how much you have saved during the last billing cycle. The solar panels produce 250 kilowatt-hour units of energy, of which 200 was consumed and 50 was exported. You have a saving of 250 kilowatt-hour units in the electricity bill. Every unit of energy produced by the solar panels, consumed or exported, will result in a lower electricity bill.